Hi, Assalamualaikum. Okay, now we are going to cover a topic sorting. Okay, in data structure and algorithm. So sorting is important in managing large data. So we have a scenario here in a library. So how long it takes to find a particular book? So imagine that you are in a library. We have hundreds and thousands of books. So it would be a difficult time for you to find a book. So that's why we introduce an indexing system. It will be much easier to find, much easier to record all the books, and then it will be better managed all the books in the library. We have the same scenario where we want to find a particular student in UTM. Okay, so for your information, we have around 10 to 15,000 students in UTM from diploma level until a PhD students level. Okay, so it will be difficult for you to find a student in which faculty, in which program. That's why we introduce a matrix number system. It will make easier to sort all the students' informations, and then after the students' information is sorted, then it will be much easier for you to find that particular student. Now, what is the concept of sorting? One of the concept is that, of course, we may make sure the list in sequence, either ascending order or descending order, from A to Z or Z to A, or from 0 until the last number, or we have to a big number until a smaller number in descending order. Another concept is sort stability. That means this is a sorting characteristic that maintains the output order as the input order in data that have the same keyword or value. So let's say we have a list. Let's say we have C, B, B, D, A. C, B, B, D, A. So remember that we have a two value with the same keyword, same letter. B, B. C, B, B, D, A. So B and B, the first B and the second B will be the list input into a process for sorting. So once these are the input before the process sorting, then the output will be displayed as A, B, B, C, D. So the first B, the second B, the order where the input sent to for processing will be the same as the output data. That's why it said that it maintains the output order as the input order. The input order is first B and second B, and the output order will also follow the input order. The first B and second B also display as it is. Okay. Another concept is sort efficiency. So the efficiency of the sorting is the expected numbers of comparison and movement needed to sort an unsorted list or linked list. So how are we going to measure the efficiency of sorting process? So if let's say the algorithm, the pseudocode, the way we wanted to make the list in ascending or descending order, we have a conditions. So we need to do the comparison, and then we need to move all the data. So how much comparison, how many movements you have to do, that will measure the sort efficiency. Okay. So another concept for passes. Passes, during sorting process, data travels many times, because you want to search all the data and then to move according for the ascending or descending order. So every traverse is called sort pass. This is the term that we use for sorting process. If the data is moved from one item to another item, that would be the term sort pass. Depending on the algorithm, a part of the whole or list may be traversed. Okay, in sorting we have internal and external sort concept. But for this particular lesson, we only cover the internal sort concept. That means any data sorting process that takes place entirely within the main memory of a computer. So that means the data reside in the main memory, in the random access memory, in your computer RAM. Okay. So let's say we run the program, you use array. So array is in the RAM, not in the hard disk, not in the file, not in the cloud. Okay. Then everything will be in your main memory of the computer. That will be the internal sort concept. So there are many sorting process, internal sort. But the common is we have 4 we cover here. Simple or selection sort. Second is bubble sort. And then insertion sort. And then quick sort. We will cover each of these sorting process in the next slides. So first we cover the simple and selection sort. So this is the most fundamental and the easiest concept of sorting. Because it implies the name simple, or we can say that it select a particular data to sort, and then it will be a selection sort. And then of course the sorting sequence can be either ascending or descending, and of course if it's ascending, then the smallest value will be put in the left. Okay. Now let's say we have an unsorted list. We have 7 data in array, so array of 7, starting with 65, 35, 25, 85, 50, 55 and 70. So let's say we're going to do the simple sorting process in ascending order. Okay, that means the smallest will be put in the left, and then the largest will be put on the right. Now step 1. And step 1 means you need to traverse, or you do the sort pass to find the smallest, that is 25. So, and then change the location with the data in the first location. Okay. First, from the 65, we need to check which one is the smallest. We found that 25 is the smallest. Then we change to the first location. Swap with the first location, and it will change position. So 25 will be at the beginning of the list, and then the rest will be still unsorted. Okay, now 25 is the smallest in the first index, the first element. Then step 2, we're going to move to the second index and check which one is the smallest. So we found that 35 is the smallest. That 35 will be not moving anywhere. It remains in the dead position for the second element. And then for the second step, the third step will be follow the first step. That means we repeat the process and find the smallest. So 50 is the smallest, then we exchange with the 65. Okay. And then 85, from this position we check which one is the smallest. Then 55 is the smallest, then we need to swap with the 85. Okay. So one swapping, then next element number 5 until the end, which one is the smallest. Then 65 is the smallest, then remains as it is. And then from this particular point, 85 and 70, which one is smallest? 70 is the smallest. Then you need to swap this 70 and 85 here, and then you have a sort completed. And once it's swapped 70 and 85, that means you have a complete sort process, and the list is in ascending order. So 25, 35, 50, 55, 65, 70, 85. You see how simple it is, but of course this is a small data, small list. It will be a 7, 10 or 15. It will be much easier and simple sort if the list is small. If a large data, it will be much trouble for your system performance. Okay, so make sure that your list is not too large. Around 20 data will be fine. Okay, now this is a simple sort. So let's move to the bubble sort. So bubble sort exchange unsorted elements systematically until all elements are arranged in the desired way. So if we compare two value, first value and second value, and then it will exchange values until the data is sorted. So let's say we want to arrange this same list, array of 7, using a bubble sort. Now, the step 1 is we compare the first two data, the first element and the second element, the index 0 and index 1. 0 and 1 we compare. Which one is the smallest? 35 is smallest, then we need to do the swapping. We exchange these two values. They become like this, 35 and 65. So after 0 and 1 is compared, now we need to compare 1 and 2. 0, 1 is compared, now we move to 1 and 2. Index 1 and 2, that means the second element and the third element is compared. So 65 and 25, which one is smallest? 25. That means 25, we need to swap this process. 25 and 65 move the position. Now 1 and 2 is already compared. Now we need to move on. We need to compare 2 and 3. Index 2 and index 3, we need this to compare and check which one is the smallest. 65 is the smallest. That means we will not do anything. It remains in the locations and it will not be exchanged. Okay, so continue the process. Once we have compared 2 and 3, then we need to compare 3 and 4. So 3 and 4, which one is the smallest? 50 is the smallest. Then we need to do the swapping, 50 and 85, exchange the locations. Okay, after we compared 3 and 4, then we need to compare 4 and 5. 4 and 5. So we need to check compare the value. So 55, 85, which one is the smallest? So 55 is the smallest. That means we need to exchange those values, because if you want to make the sort ascending order, the smallest will be put in the left. So we need to swap this value, and then once swapping, then it will continue until the end of the list. Now we have compared 4 and 5. Now we continue 5 and 6 index. So 5 and 6 we compare which one is smallest. 70 is the smallest. Then exchange these two values, 70 and 85. So is it end of the list? Yes. So once it's already end of the list, we need to check whether is this data is sorted. No, because 25 remain in the middle, and somehow 65 is not here, should be in the right position. Okay, so if let's say once we compare two value until the end of the list and check if the list is not sorted, then we need to repeat the whole process again. Okay, so from 35 until 85. So the first two, 35 and 25. So 35 and 25, which one is the smallest? 25. So we need to swap or exchange these two values. So 0 and 1 is already compared. Now we're going to compare 1 and 2. So 1 and 2, which one is the smallest? 35. So 35 and 65 remain as it is. No need to exchange. And then we need to compare 2 and 3. So 2 and 3, which one is smallest? 3 is the smallest. 50 is the smallest. Then we swap 50 and 65. And then we continue the 3 and 4. The fourth element with the fifth element. The third index with the fourth index. And then we need to check the value. Which one is the smallest? 55 is the smallest. Then 55 move, exchange with these two values. And once it's exchanged, then we continue the process, compare with 5 and 6, then 4 and 5, 4 and 5, and then compare with whether 65 and 70, which one is the smallest. Nothing is exchanged and it remains as it is. And then the last one will be the element 5 and element 6, the fifth index and the sixth index. And that means the sixth element and the seventh element. You need to compare and check whether is it 70 is the smallest, then it will not exchange, it will stay as it is. So now it's already end of the list, and check whether is it the list is sorted. So 25, 35, 50, 55, 65, 70, 85. That means the list is sorted. So if let's say the list still is not sorted, then you need to repeat the whole process again, starting from the index 0 until the end of the list. Remember, this is internal sort. It will better or give a better performance or good efficient. Will be the list is no larger than 20 or 25. Smaller is better. Okay. Now, what is the efficiency for bubble sort? The worst case happen when the list that is to be sorted is in the order that is reversed from our desired order. So in this case, the only element, the biggest, will be sorted in every loop. That will be worst case happen for a bubble sort. So this is how we going to measure the bubble sort. So every time we exchange and compare, we need to do the n-1 times throughout the process, and then we need to compare from the beginning again until the end for the second loop, and that means the n-2 times until the end of the loop. We still go on and go on. That's why we have an n-1 plus n-2 until it will reach at the end of the list, and then it will check again the list whether sorted and repeat the whole process again. There will be n times n-1 divided by 2. That will be the formula. So once we analyze this formula with a big O notation, we remove the efficiency coefficient, and then remove the largest, and we remove the smallest, then we have the largest. N squared will be the worst case scenario for the bubble sort.